What's up guys, Design Syndrome here. Once a year or so, I like to open up my case to clean it a little bit, maybe update a component or two. So I figured this was a really nice opportunity to take you along that process of putting a workstation together yourself, while I explain an overview of the function of each component and how I would pick them myself if I was building a creative rig from scratch. It's kind of a long process that needs to have some thought put into it, but it's not big issue really if you take it slow and you know what to look for. I mean, compared to now, when I built my first PC, I literally didn't know what I was doing. I remember going back and forth, changing components because there was a little thing that I missed, a compatibility issue or whatever. So this video I'm making to help you save a lot of that hassle, you know? And if you're still leaning more towards on getting a pre-made or a laptop, then still the information in this video will be of tremendous use to you to know what to look for, what you're getting, and what all the specs really mean. Now, what I've been wanting to update for a while now, it's my case. I have the new one right here. Also, my partner, aka the editor, is putting her own workstation together. So some of my components will go to that PC and I'll update some of mine. So if you're a graphic designer or digital artist as myself and you're looking to get a proper workstation together, then this is the video for you. I already have my components unassembled over there, so I guess we'll go from there as I put them back in. Let's get it. But okay, first, why is it important as designers or anything really to have a basic understanding of how our tools work? Imagine being a driver. Having an understanding of how your car works puts you in a much better spot to understand what can be done with it and what can't. So establishing a connection between ourselves and the tools we use, be it a computer, a pencil, a brush, even our own bodies, understanding the basic principles that makes them function allows us to work more efficiently and solve problems creatively. And just as drivers can troubleshoot basic car issues, having an understanding of how your computer works can help you get out of a jam when you need to fix something hardware or software related. So you are not left stranded with a brick PC till you can get it to the service. I know it had happened to me. Plus, starting to care about how things work can enable us, as we start to see the pattern that governs all of reality, to come up with ideas that respond and are in tune with this cosmic rhythm. Yeah, but also doing it yourself can be cheaper, more fulfilling than just buying a box and hoping for the best, you know what I mean? So with that out of the way, let's begin. Now, let's start for the most important part of your build, your CPU. CPU for short, or Central Processing Unit. It's what executes everything, your operative system. It's basically what runs your rig. And when it comes to GPUs, the more prominent terms you'll come across are gigahertz, that in short, it's the power of your GPU. More gigahertz, it's more speed for your rig. Modern CPUs come with multiple cores. Each core can handle its own thing, meaning that in more cores will lead to usually a better multitasking performance. From this stems two routes you can go for. You can go either less cores with more power individually, or you can go for more cores with less power. And now comes a canon decision of your life, to the level of what Pokemon did you choose at the beginning of the Pokemon game. You either go for an Intel CPU or an AMD CPU. What's it gonna be, baby? Team Blue or Team Red? Are you a Blastoise or are you a Charizard? It's not that deep really. This is important because the brand that you choose will determine later down the line which kind of motherboard you should get because of the socket in which the CPU goes. For that reason, it's important to pick your CPU first. Intel usually provides the best single core performance, while AMD tends to provide more core counts on their CPU lineup. And from my experience, they tend to be most cost efficient, meaning you'll get the most bang for your buck. Which one you go for will depend on your workflow a lot. More cores will be beneficial if you do a lot of 3D or video editing. Anything you're going in and out of a lot of softwares, then the multi-core counts come really handy. On the other side, less cores with more power per core tend to be better for performance in design-specific programs like Illustrator, Photoshop, InDesign. Also, if you're planning to do some gaming, usually higher clock speeds tend to yield more performance on games. Although for sure you can game on a multi-core. I game on a multi-core and that rips, you know what I mean? We have a snippet from the Photoshop site itself where it states, the speed of the computer's central processing unit or CPU limits the processing speed of Photoshop. Photoshop generally runs faster with more processor cores, although some features take greater advantage of the additional cores than others. However, you'll get diminishing returns with multiple processor cores. The more cores you use, the less you get from each additional core. Therefore, Photoshop doesn't run 4 times as fast on a computer with 16 cores as on a computer with 4 cores. For most users, the increase in performance that more than 6 cores provide doesn't justify the increased cost. So there you have it. Also guys, like this video and subscribe because we're doing scripts now. Like, take a look at this. Like, appreciate the content, you know what I mean? This is the motherboard. Think of it as the backbone of your computer. It's where every other component connects and communicates with each other. And remember how we picked the CPU first? Well, that comes into play now because different motherboards come with different sockets for the CPU. Intel uses LGA sockets and AMD uses AM sockets. The naming will change a bit with time. Mine, for example, it's an AM4. It's that information you'll find super quick if you look at the description of any processor you're interested in. So now that you know your socket, motherboards have another crucial part that you need to take into account. That is the chipset, which is usually a set of letters, then a set of numbers that go before the whatever brand of the manufacturer is. This one, for example, is an Aorus X570 Pro Wi-Fi, X570 being the chipset, which determines the compatibility with certain CPUs and some features being available on the motherboard. Here, what you should do is to look up which is the current generation of chipsets available for the socket of the CPU you want. LGA from Intel sockets have another set of chipsets and they come in 3 tiers. They usually come in a consumer tier, an enthusiast tier, and the professional tier. I would almost every time advise you to go for the middle tier or maybe some low end of the premium tiers, unless you know what you're doing or maybe you're going for some crazy overclock. If not, just stick to the good ones from the middle tier. I wouldn't go for the low tier motherboards or the very cheap ones because you start to lose on connections for hard drives, your high-speed USB ports, things that as a creative you're gonna need for peripherals or hard drives and stuff like that. But again, always go into the website of the manufacturer of the motherboard you want, and under the description they usually have a tab where it states all the compatibilities and all the different ports available on the motherboard. So on there, check for the CPU, USB ports available, and the options for storage that they have. Here, another tip I can give you is try to not go for the shiny, just released new tech. Let a couple months go by after the launch of whatever product you want. 1, because of price, and 2, right out of the gate, components sometimes come out with issues that maybe that get corrected on BIOS or driver updates, sometimes entire revisions on the product. For example, the previous graphics card that I got was a brand new model that I fell for the FOMO on, and I got it the week it was out. The problem with it was that it was running at too high temperature. It's not a really big problem, really, not optimal. If maybe I had waited a couple more weeks till more reviews came out, I would have chosen another model for sure. So control your hype for this kind of stuff. It will save you money every time. Control your hype for everything. I mean, you don't want to get heartbroken because of some video game, that came out that didn't live up to the hype. Also, don't buy super cheap, like old 2 generations back hardware, because it's likely that when you feel the need to change anything in the future, you'll have to change everything again, because old hardware doesn't go well with very new hardware. They tend to have some sort of leeway compatibility spectrum, right? But it's not too wide, so don't go for super cheap old hardware. Now that you know, let's install the CPU. To work with your motherboard, put it over a surface that won't conduct any electricity. I like to use the cardboard box it comes with, so I'll put it over that. For extra protection, you can plug the power supply you'll be using while it's off and touch any of the metal parts to ground yourself every time you go away and come back. You could also use an anti-static wristband such as this. To use it, just wrap it tight on your wrist or ankle and clip it to some bare metal part of your plugged and off power supply to prevent any static charge you might be holding of potentially reaching and damaging any component. To be fair, really, in my years working on my computer, this never happened to me. The chances are very minimal, but hey, if you're working with very expensive components, I'd rather be safe than sorry. This is an AMD Ryzen 9 3950X. AMD processors have these pins here on the back of the chip itself. They're actually really fragile, so handle them with care. To put it in, just match this little triangle thing on the back of the corner of the chip with the one on the socket. Slide it in, pull this lever down, and you're done. I know we're missing the cooler for this, but we'll install that later. These are RAM sticks. It's like your short-term memory. It stores everything that you're doing at the moment with your computer, and it gets cleared every time you turn it off. More RAM allows for handling larger files and running multiple applications at the same time. They come in sticks. These ones are Crucial Ballistics DDR4 3600 MHz. The DDR4 stands for the generation of the RAM that you need to check your motherboard is compatible with. Every couple of years a new generation will come out, then a couple years more it becomes the standard, then the cycle repeats forever. The 3600 MHz in short is the speed of the RAM. For a beginner creative doing graphic design and some light video editing, I would start with 32 gigs on dual channel, so that would be 2 sticks of 16 GHz, and you still have room to add another 32 later. Faster RAM can improve overall system responsiveness and task execution speed. Here you might want to check online which combo is best for your CPU, since a good pairing of this can bring even more performance to the table. This is even more noticeable on AMD CPUs. Here most times you'll be good with a 3200 or 3800 MHz for your RAM. There is also the issue of the cache latency, which is the sequence of numbers on the back of your RAM sticks. Lower timings on your RAMs makes them quite faster, but I wouldn't bother with this yet, since the cost starts to ramp up pretty fast, and I think your money is better invested elsewhere in your rig at this moment. To install them, it's really easy. Just pull this lever up, slide it, and push evenly till it clicks. If you're only using 2 sticks, make sure you are using them in the right channel for both. Here, check the manual real quick to identify the slots. Then under memory configuration, check the correct placement of the sticks if you're only running with 2. And in case I needed to clarify, always use the same model, same brand, same everything for optimal performance with your memory sticks. Don't mix them, please. What's next? Cooling. Your GPU will come with an integrated heatsink and fans ready to go built. Your CPU, on the other hand, might not. Won't come with an included cooling solution. Here you can go either water cooling or air cooling. If you're going to do some serious rendering or video editing, you might want to lean more on the water cooling, because the sustained effort of your components will lead to more heat, hindering your performance and possibly deteriorating the lifespan of your components over the long term. For anything else, just go for a high-tier air cooling tower that in some cases they even outperform the mid-tier water cooling solutions. Me, for example, I have a really high-end powerful CPU which I cooled with this Be Quiet Dark Rock 4. Even made some renders with it, no problem at all. For me also air, I don't know, it's more practical, and having the thought of not having to deal with a leak possibly suits my mind, I don't know. This Dark Rock will go to my editor's PC, and myself, I'll be swapping it for an Noctua Chromex cooling tower. To install any aftermarket cooling solution, you usually need to change the mountings on your motherboard for the ones that come included in your mounting system. They come with a few, you need to grab the one that's for your socket. A quick glance at the manual will tell you which one and how to install it really quick. For these ones, we just need to unscrew here to get rid of the original one. There is no need to change the backplate for this cooling tower. Now with the new standoffs in place, here, silly me, I actually got confused and grabbed the other pair, so I changed for the correct one. Now, don't make the mistake of just slapping the cooler on, because you see, CPUs generate a lot of heat. And you see, the way they work is the plate on top of the CPU makes contact with the one on the bottom of the cooler. Heat goes through and up the pipes to the aluminum fins, and the cooler just blows it off. Now, to make that contact the most efficient, we need to use this thermal paste, because it doesn't matter how smooth the surfaces seem to be, at a microscopic level they still have imperfections. Those create gaps in the contacts, and that's a big no-no for heat transfer. The thermal paste comes in to fill those gaps. To apply it, you're gonna see a lot of ways out there. I always did like a big grain of rice. Don't use too much, but also not too little. This is gonna ensure a nice spread when we press down with the heatsink. Let's press it down now, screw here and here, and done. Now we have storage. This is your long-term memory. It's where all your files and your windows get stored. We have a few types to go for and they impact performance quite a bit. First, we have HDDs or hard disk drives. These ones are really dated right now. They use mechanical parts to read and write your files. These are super slow compared to other options right now, but also super cheap for the amount of storage. I use them personally to store like large archives of files that I don't use every day, such as old completed projects or resource libraries. A quick plug, buy my assets, you know what I mean? But remember, these are mechanical. They have moving parts, so they are prone to failure. This have never happened to me, but it is what they say, so keep that in mind. Then we have SSDs or solid state drive. These ones uses flash memory with no moving parts like a giant USB pen drive. These are more expensive, yeah, but the speed is night and day. Quicker boot times, faster file transfer, faster loading times, so you can die faster on Elden Ring. These are your go-to for daily usage. In my system, I have a few. I like to have one extra for games and to use as a scratch disk for Photoshop. They use a SATA connector, such as the one I'm showing you right now, and we'll install them after we start putting things onto the case. Lastly, we have SSD, but from another kind. These ones are NVMe SSDs or non-volatile memory express. This is a subtype of SSD that connects via the PCIe interface, which is even faster than SATA connection than the other drives that we just saw. They are even more expensive, but the performance jump is not as noticeable as from going from an HDD to an SSD, you know what I mean? So I wouldn't really invest in one of these if the rest of your rig is lacking in some way. First, you need to check your motherboard actually supports first an M.2 slot, which is this form factor, and also that it supports the PCIe interface. This one we can install right now. We need to lift this cover here. My mother has a heatsink for this one. You also might need to install these little standoffs. They are to accommodate for the length of the NVMe drive, and they should be on the box of your motherboard. Just screw them in, then slide the NVMe drive into the PCIe bay. You'll see it has like a matching indentation, and then lightly press it down to screw it to the standoff you just placed. Then screw the heatsink back in place. Now comes the case. It's the box where everything goes in. They come in many shapes and sizes. Mid-tower is the format where it's at for almost everybody. Also, one thing that I forgot to mention on the motherboard section, which is the format of the motherboard. ATX is the standard for all mid-tower and full-tower builds. You have larger mobos and then you have smaller mini ATX mobos, but we don't bother with those still. Then if you're gonna go and build one super tiny hyper powerful build as you see on YouTube, go ahead.
How much performance can you squeeze into a compact $2,000 PC build?
But this is a beginner's guide, so mid-tower ATX mobile, please. On this part of the build, maybe don't drop all of your cash at, but do, however, watch some reviews or recommendations on the specific case that you want to see that it has good airflow and also that it has clearance for the components you want. GPUs are getting ridiculously big nowadays. I'm swapping my old NCXT for this one, that's the newest model, because of that specific issue. I was having too powerful components on a tiny enclosed space, and that was rising the temperatures a bit too much for my liking. It's not the end of the world, but not my preference, because components, if they get too hot, they start to throttle, to thermal throttle, which decreases the performance. I even had to remove the front shield because with it on, the temperatures would shut off my PC. So yeah, it also is not aesthetic. Like, look at this, crazy. You know what I mean? It speaks to me. So now let's mount the motherboard with the components we have already installed in the case. The mobile has these holes that you need to line them up with the standoffs on the case. The screws for this should be on your case box. Huge tip for doing this, get a magnetized screw set if you can. I can't tell you the amount of times that a screw got lost and I had to wiggle the entire setup just to bring it out. This set is crazy, I'll leave you the link for it below, alongside some other cool stuff to help you save even more time, but more on that at the end of the video. Now comes the time you've been waiting for. It's time for the big boy. Your graphics card. Your GPU, or your graphic processing unit. It handles the rendering of images, videos, and animations. It plugs directly into your monitor, translating anything that happens on your rig to an image you can see. It's the most expensive component, and you don't need to go super heavy on it unless you're planning to do some heavy rendering or video editing. I mean, also if you're planning to game on it, you know what I mean, but this is a professional workstation, not PlayStation. No games will be played on this. Republic of Gamers. What? Another thing that you need to have in mind is what kind of display you're gonna be using and what kind of content you're gonna be editing. For example, if you're gonna be editing 4K footage on a 4K monitor, you'll need a hefty, powerful GPU to move that amount of pixels. You know, more pixels, more power. One quick note on the monitor. Me, for example, I use an ultra-wide monitor. It's a 2K, so it's 1440 by 3440, I think. And I think it strikes a nice balance between image quality and the price. 4K monitors go crazy, and if you're gonna use it to work, IPS panels give the better resolution and color accuracy, right? If you go for a TN panel to get those sweet high refresh rates for gaming, you do you, but I feel it's better for working and striking that professional gaming balance, you know? Going for an IPS monitor, it's the best that you can do. We can do an entire new video on monitors alone, but just a quickie, go for a 2K monitor, IPS panel, they look great. Back to the GPU. In this space, the most prominent vendors will be AMD and NVIDIA. Your enchant for NVIDIA would be the RTX 4060 for consumers, 4070 for enthusiasts, and 4080 and 90 for professionals. A 3080 like my own would be the top card for the previous generation, the one from last year. You'll see other things attached to the name sometimes, like Turbo or TI or whatever. These are the same versions with a little bit more oomph, you know, to get your eye and force you to fucking buy. And when you're shopping, you'll see a plethora of other brand names attached to the main GPU name, like Gigabyte 3080 Ti. This is because of the business model that, for my understanding, NVIDIA, they are the ones that designed the original chip, like the founders for the 80, for example, that I'm showing you right now. And they sell those designs to other manufacturers so they can come up with their own tweaked design and cooling solutions, like the Aorus 4080 and so on. From there, all the brand names that you see. But listen, don't get overwhelmed. These are all the same card with a few tweaks and changes to the design. So just make a quick Google search, which is the best 4080, 4060, whatever you want, and usually they'll tell you. NVIDIA is the one leading the space with all their work on artificial intelligence, super sampling, and ray tracing. So if you're doing some video editing or 3D work, I would go for NVIDIA almost 10 out of 10 times. But again, I don't know when you're watching this, maybe AMD catches up in the near future. I don't know. I'm just trying to make a video with some loose guidelines so you can watch this whenever and make a choice that makes sense. And also another thing that's kind of different than for motherboards, for example, that I told you to go for the middle tiers. From a couple of years now, graphics cards have been getting pretty powerful and inefficient in the last couple of years. So any from the latest cards that you can get from here to maybe 3 years back, you'll be golden on the entry level for doing 1080p stuff. That would be the 2060s, 3060s, 4060s, super powerful cards for entry level stuff. Then if you start to move upward with some 3D work, maybe video editing, a 3070, stuff like that, it's where the sweet spot is. And then if you can spare it, 3080, 3019, you'll be good for a couple of years. So now, time to install this bad boy. First, we need to unscrew the case back covers for the GPU slot. Press this lever on the side of the port, then slide the card in till you hear it click, and then secure it back to the case with the screw you just removed a moment ago. And I'll be using this GPU stand to keep the card from sagging from its weight and potentially damaging the motherboard socket. Now, last but not least, from your main components is your PSU, your power supply unit. It's the power source, the heart of your computer. It's what provides the juice for every component. Power supplies come with a wattage, that is the amount of power that they can deliver. They have also a certification like 80 gold, for example, or bronze or platinum, which hints at the efficiency of the power supply for supplying that power consistently. There are websites that you can use to calculate the wattage you'll need to run your rig. My advice is to calculate for 20 or 25% more, so you have wiggle room to update your computer in the future. better. And listen to me, don't cheap out on this one also. Go for gold certification at least from a major reputable brand. These are from the easier components to manufacture. You'll see a bunch of lesser known brands selling you 800 water supplies, dirt cheap. And believe me, you don't want your workstation, your cheddar making device relying on some sketchy off-brand piece of tech. You go cheap on a RAM stick, worst thing that can happen, you get less performance. No big. You go cheap on your power supply and you could kill some component. In a heavy client week, it could be your worst nightmare. So remember guys, don't pair your $700 GPU with a $70 power supply. Please, believe me, I know. Now, time to install it. The power supply has cables that you have to route to the components of your rig. This is why modular power supplies such as these ones are so handy, because we can choose and only use the cables we need so we don't have an excess of cables that's hard to keep organized. Just pay attention on the labeling on the cables and on the socket of the power supply. So first, let's connect the big boy, the 16 pin that goes directly into the motherboard. Just route it down the middle of the case. They usually have a window for it. Just curl it a little bit, press evenly in the socket till you hear it click. And let's route it to the bottom of the case to install it in the PSU later. Next are the PCIe cables to provide power to our graphics card. These ones we're gonna route down the bottom of the case. They usually have an opening for these ones. And a quick note for the CPU, if you'll find these are the cables that you need to plug into your graphics card. You'll see they have this kind of splitter. Don't use them because it seems that they don't deliver power as efficiently as the main one. Even my power supply came with this little note to tell us to not use the splitters, as you can see. Here the correct way, and you can see how it uses all three main connectors without the use of the splitters. So yeah, I don't know why that is. Mine only came with 2 PCIe cables, so I had to order a spare from the manufacturer's website. So these are the ones. Make sure if you have the need for this, make sure you order the ones that are specifically for your power supply. You don't want to mix them. I've connected this graphics card using 2 main ones and 1 splitter, and it works fine, but I don't want to risk it. I'm just gonna use the 3 main ones now. Just a little tip. I don't know why they even manufacture the splitters if they are no good. Like, why? So yeah, just connect those into your graphics card, route it down the bottom. We'll connect them to the PSU later. Next, we have another 8 pin that's for the CPU. Connect it till you hear a click, and some motherboards will actually have another 8 pin or another 4 pin, such as mine. This is to provide additional power to the CPU in case it needs it. So let's do that. Let's route that down the top of the case to connect later. You'll also find this string of cables that you need to connect into your hard drives and for any other devices that you may have, such as fan hubs or RGB hubs. Here I'm gonna mount my SSDs into the little base that come included with the case, and once they're done, I'm gonna just plug down the bottom the power cables, and I'm gonna take also this opportunity to route the SATA cable also from the drives to the motherboard. I'm gonna connect them and route them down the bottom. They're kind of close to my graphics card. I always do this. I should have left the graphics card for last because it's so big that it creates clearance issues when it's time to connect other stuff. I always do this. I don't know why. Maybe I like to see it on there, but yeah, leave it for last if you can, and plug everything in and then put it in because it will be far easier then. It's time to place the fans. And here are some things that you might need to take into account, such as temperature and the direction the air flows within your case. And I mean, there are dedicated videos that specialize in this information, so I try to make it quick. You basically want an equal amount of air or more coming into your case than coming out of your case. This means having more fans intaking air than outtaking air. This will create positive pressure within the case. If you have more air coming out of the case than coming in, you create like a little void inside the case, which will start to pull in air from the crevices and little holes in the case, actually drawing in more dust into it, and you'll have to clean it often. And also prevents some of the hot air to not leave the case, actually raising your temperatures, hindering performance, so no. And lastly, how we all know, hot air rises. So we would want to place the intake fans on the front and bottom of the case and leave the outtake fans to the back and top of the case to go along with the natural movement of air. To know the direction of your fans, just take a look at your fan and you'll see the front that doesn't have anything and the back has this like plastic structure. This is the back of your fan. The air will flow like so. Almost all cases will come with a set of fans. The stock NCXT ones that come with the case are cool, and I'll keep them as exhaust fans. As intakes, I'll be adding this set of Be Quiet Pro Wings levitating ones for better airflow and less noise. And since they're a bit better, they'll create a bit of positive pressure within the case. To install them, just screw them into the factory holes that come with the case and make sure it supports the diameter of fans you want. To power them, nowadays, fans come only with a 4-pin connector that you need to plug directly into your motherboard. Check the manual for the system fan 4-pin headers that you need to plug them in. And pay attention also because the motherboard has a specific connector that's for the CPU coolers. Because this one needs a bit more of monitoring and control, so you know which one you're controlling later in your specific programs, you know. They are usually close next to your CPU. If your case comes with fans that have a 3-head pin, just plug it into the 4-pin connector on your motherboard. Just follow the small indentation on the side and make it click. You will leave 1 pin hanging, but that's okay. 3-pin headers usually run at a constant speed, so you can't control the speed in which they go, so no big deal there. At least for your outtake fans. Make sure your intake fans are running on a 4-pin header, right? So buy the cool ones, the nice ones. When plugging the system fans, look for them all over your motherboard because they are pretty spaced out to allow you to connect them from all various angles so you won't miss a spot. So you don't have all cables running through the same opening, you know? So try to spread them out so you can get a clean cable setup, you know? Mine, it's so-so, it's not great, but I've done worse. Like this is nice, this is cool. Now let's connect the components' power cables to the PSU. Just follow the labeling and plug them in the right spot. It's pretty straightforward. From there, just slide it in the PSU compartment on your case. Mine, it's free, I just slide it in, but yours might have a bay with a little case that you need to pull out maybe. Pay attention on the fan on your power supply, and if it's gonna suck air from the top, make sure your case have openings on top of it so the fan is not facing like bare metal, you know, it won't have any air and it will suffocate. Mine here, it's gonna kind of steal some air from the graphics card, but let's just run it as it is and we'll see. If it gets too hot, I'll swap it to suck air from the bottom, which I don't really like because of all the hairs that go about of my dog. So let's just try it and see what happens. We're almost there, guys. The RGB lights, if you're gonna use in your build, it's scientifically proven that more RGB actually boosts performance. I did get some nice RGB lights, but now that I'm seeing the build, I guess I'm gonna go for a total black. I'm gonna do just a small RGB lights to sort of light the inside of the case to be able to see the components are functioning. That's important also. Maybe it's not aesthetic, but to allow you to see what's happening inside your case, maybe it's cool to have some little lights in there, you know? So yeah, RGB lights have their own headers within the motherboard. They are the ones that I'm showing you right now. Look for them on the manual. You just route the lights however you want and you just plug them directly there. They come in 2 variants. You have a RGB that will allow you to control each specific LED on the strip, allowing you to create all those flashy effects you see on Pinterest. And then you have just plain RGB strips that can only glow one color at a time. But hey, if you already know what color you're gonna use, you might as well go for one of those. RGB lights go in the 3-pin header on your motherboard, and just RGB light connect on the 4-pin header. The RGB lights consume a bit less power. Fun fact, I don't know. To connect them, make sure you match the little arrow thing on the connector of the LED strip to the pin on the mobile that's for the voltage. You'll know it because it has a little B on the bottom. Now, my guys, we are left with the hardest part of the build. This is the bane of my existence. It's the front panel pins. This route the buttons on ports on the front of your case to your mobile, so they work basically. Cables for USB ports and so on are labeled, so take a look at the manual and you'll find where they go right away. For the power up button and LEDs, just check the labeling on the small cables and look for this section on your manual. Once that goes in, you're completely done. Oh, the power supply wasn't on. Well, there you have it, my guys. We even had it to boot to screen. everything working perfectly. Now I'll be doing a clean Windows install. I'm gonna leave you the link down below or over here for the video on how to do that. It's really easy. And also, to help you save even more research time, I've created a blog post with a list of ready-to-go components to put together a graphic design or a video editing rig, both in a budget and in a more beefy configuration. Go check those out. I've also thrown in some laptop recommendations. So that's it, my guys. Hope this video was of use to you and helped you learn something about the tools we use every day to make art or design. Remember to subscribe and click the notify bell button down below so you don't miss any of the future videos coming your way. And stop by the store maybe, where I have a bunch of free and paid graphic design assets to help you save time Googling and put it where it counts, experimenting on your graphic design journey. So you already know how it is. See you on the next one, ninjas. Fuck peace, wish you conflict, shit.